In this situation, we have a rational equation. Rational equations are where you have these polynomial denominators. And what you want to do in these situations is you want to multiply by those unwanted denominators. And so before we do that, we'll kind of clean this one up here. The x squared minus 9, that's a difference of squares. So you want to be really familiar with that format. If you have two perfect squares with a minus sign in between, it's going to factor to the square root of each piece with a plus and a minus. So this square x squared minus 9 is going to factor to x plus 3, x minus 3. So we're going to have 4x squared over x plus 3, x minus 3 minus 2x over x plus 3 equals 1 over x minus 3. So we said that for rational equations, we want to multiply by our unwanted denominators. So we have two unwanted denominators. We have x minus 3 and x plus 3, and we're going to multiply by them both. So x minus 3, x plus 3 for this side. Actually, let's show that a little bit better. Let's shrink this. Okay, so we are going to multiply both sides by x plus 3, x minus 3. When you distribute here, everything cancels, leaving you with 4x squared. When you distribute here, the x plus 3's cancel away, like that, leaving you with 2x and x minus 3. So minus 2x and x minus 3. By the way, a minus sign in that spot right there tends to cause a lot of trouble. Most of the people who would miss this question would miss it because of that minus sign. So that's why the better thing to do here is to attach it to the 2x, where it's in a safe place where we're less likely to lose it. Now, when we distribute here, the x minus 3's cancel, leaving you with x plus 3. So now we're just doing our quadratic solving. We have 4x squared minus 2x squared plus 6x when we distribute this and this equals x plus 3. Combine some like terms. 2x squared plus 6x equals x plus 3. Take away x and take away 3. 2x squared plus 5x minus 3 equals 0. And now it looks like the classic way to solve from here is going to be ABC factoring, because we have a quadratic in an ax squared plus bx plus c format. And so for ABC factoring, we're looking for two numbers that add to b and multiply to AC. So two numbers that add to b and multiply to AC. So for us, that means our two numbers need to add to 5 and multiply to 2 times negative 3, which is negative 6. And what numbers do that? It would be positive 6 and negative 1. So we're going to split the middle term into 2x squared plus 6x minus 1x minus 3. So we took the 5x and we replaced it with 6x minus 1x, which is okay because 6 minus 1 is 5. So we really didn't break any rules of math. Now we're going to want to do GCF factoring for the first two terms and for the second two terms. And this is the ABC factoring method. So we found our 6 and negative 1, and we split the middle term. Then we're doing greatest common factor for the first two and for the second two. So the GCF here is 2x, and it leaves you with x plus 3. And the GCF here is negative 1, which leaves you with x plus 3. If you're a little iffy on the signs here, just write what you think it is and then distribute it to see if it worked out correctly or not. So negative 1x minus 3, and that's perfect. Now you take out the GCF of these two terms. This is one and this is the other, and they both have a greatest common factor of x plus 3. When you take that out, it leaves you with 2x minus 1. And we've factored this thing out, and it still equals 0. So now we're going to use the zero product rule, which is simply the idea that if these two parentheses are multiplied together with an answer of 0, you set each individual one equal to 0, and you get your two answers that way. Take away 3 from both sides, add 1 to both sides, divide by 2, and we have negative 3 and 1/2. Now, there's yet another issue here. For rational equations, you always want to check your answers at the end by plugging them back in. And so here, there are going to be plenty of people who really did kind of understand what to do and got this far and still got it wrong, because negative 3 can't be an answer. When we go ahead and plug that in, x equals negative 3, we will get 4x squared over x squared minus 9. We don't have to plug it in everywhere. We have to just realize that right here, we would have negative 3 plus 3. And so if we were to plug in x equals negative 3, we would end up with a 0 in the denominator. And that's not allowed. So that part created a 0 denominator. So we could not accept that. And so the x minus 3 was bad, but when you plug the other one in, it ends up being good. So the answer here is just 1/2.